If cross product is defined such that a cross b is 2a squared plus 3b, then what is 4 cross 2? This is a pretty clear-cut template for us. Notice that a corresponds to 4 and b corresponds to 2. So in this case, a cross b being equal to 2a squared plus 3b is the same as 4 cross 2 being equal to 2 times 4 squared plus 3 times 2. Therefore, the result is 2 times 16, which is 32, plus 3 times 2, which is 6. Which of the following is equivalent to 2 tangent squared of x cosine squared of x? 4 sine squared of x, 2 minus sine squared of x, 2 times 1 minus cosine squared of x, or 1 divided by cotangent x secant of x. First thing we need to remember is the definition of tangent of x, which is sine of x divided by cosine of x. Therefore, 2 times tangent squared of x cosine squared of x, in simple terms, is 2 times sine squared of x divided by cosine squared of x times cosine squared of x. The cosine terms will cancel out and give us, finally, 2 sine squared of x. However, this isn't one of the given solutions. Well, not so quickly. Remember the identity, that cosine squared of x plus sine squared of x is equal to 1 for all x. Applying this identity to express sine squared of x, we get that sine squared of x equals 1 minus cosine squared of x. Therefore, multiplying this by 2 gives us 2 times 1 minus cosine squared of x, which appears as option 3. Pro tip when solving trig: always try to express derived trig values in terms of sine and cosine. How many numbers between 20 and 70 meet both of the conditions below? A, the number is prime, and B, the product of the digits is 6. We gotta find all the numbers that are both prime and have a product of digits equal to 6. First, we should probably find those numbers whose digits have a product of 6. If we express the number as xy, we need x times y to be equal to 6. For whole numbers, there are 2 such pairs, 1 and 6 and 2 and 3. Combining each of them, we see that 16 is not in our desired range, 61 is in the range and is prime, 23 is in the range and is prime, and 32 is in a range but isn't prime. Therefore, the numbers we're looking for are 23 and 61. So there's 2 such numbers. Which of the following is not an x-intercept of y equals x to the third minus 4x squared minus 21x? And these are the possible solutions. Well, let's remember the definition of x-intercept. X-intercept is a point where the function intersects the x-axis, that is, where its value is equal to 0. All of the y-coordinates listed are 0, so we can't eliminate any outright. So we will have to check whether the value of the function at each given x is equal to 0. To make things easier on ourselves, let's factor out the x from all the terms, giving us y equals x multiplying x squared minus 4x minus 21. Placing the x in the equation with negative 7, we see that y being equal to this expression is not equal to 0. Therefore, the first option, negative 7, 0, is not an x-intersect of this function. A line is tangent to this circle. 25 equals x plus 1 squared plus y plus 4 squared at negative 4, 0. What is the slope of that line? Here's a nice GeoGebra drawing that represents this situation. The circle that is described by this equation has a radius of 5, and its center is at negative 1, negative 4. Please remember the definition of a circle equation in Cartesian coordinates. The key to solving this problem is to remember 2 things. The first one is that the tangent to a circle and its radius form a right angle, its radius emanating from the point where the tangent intersects the circle, which is right here. And the second fact is that in Cartesian coordinates, lines at right angles to each other have slopes which are a factor of negative 1 over k of each other. Or in other words, if we have a line which is kx plus n equals y, then any line that forms a right angle with it is going to be of the form negative 1 over k times x plus some m. We can calculate the slope of the tangent to be negative 1 over k by just finding the slope of the radius k from the 2 points a, negative 4, 0, which is the intersect of the tangent, and b, negative 1, negative 4, which is the center of the circle. We calculate the slope of the radius line as negative 4 minus 0 divided by negative 1 minus negative 4, giving us finally negative 4 over 3. Therefore, the slope of the tangent at negative 4, 0 is negative 1 divided by the slope of the radius, which is 3 over 4. Builder is working on a new fence for a house. He needs to buy 1 2/3 cans of paint for every panel of the type shown below. Each panel is surrounded on either side by a single post with only one post between adjacent panels. The fence will cover 3 sides of the backyard and each panel will connect except for the 2 end panels. Each side will contain 5 panels. How many cans of paint in total will the builder need to buy if each separate post requires 1 can of paint? And we have a very nice diagram here showing us exactly what the backyard looks like. What we can notice right away is that we're going to have a post right here, and then we're going to have a pattern of panel, post, panel, post, panel, post, and then panel, post, etc. From the text of the problem, we know that there will be a total of 15 panels of fencing, and that means that the total amount of paint needed for painting the panels is 1 2/3 cans of paint per panel times 15 panels equals 25. Now the number of posts will be equal to the number of panels plus 1, since they're arranged in an alternating fashion, but the sequence must start and end with a post. Therefore, we're going to have 16 posts, requiring an additional 16 cans of paint. The final answer is therefore 41. A right triangle's hypotenuse is twice as many inches long as one of its legs. Which of the following must be true? The remaining leg of the triangle measures square root of 3 inches. The triangle is similar to all right triangles with one angle measuring 60 degrees. The 2 legs of the right triangle are equal in length, or the triangle is congruent to a right triangle which has a hypotenuse measuring 8 inches and one leg measuring 4 square root of 3 inches. First thing that we can do is we can discard A since there are no exact measurements mentioned. This leaves us with 3 options. However, notice that a hypotenuse being twice as long as one of the legs is a very special property. This property tells us that sine of alpha is equal to 1/2, where alpha is the angle opposite the leg in question. This is one of the 5 characteristic values of sine that you should be familiar with. You cannot use a calculator for this, so you should remember that sine of 30 degrees is equal to 1/2. We can now see that the final angle of the triangle must be 60 degrees, since the sum of all inner angles of a triangle equals 180 degrees. Therefore, the answer to this question is B. The triangle is similar to our right triangles with one angle measuring 60 degrees. If we take a look at D, this also has a configuration of 90, 60, 30 degrees on each of the angles. However, the triangle is not congruent because to be congruent means to be identical in both the length of the sides and the size of the angles. A triangle defined as in the problem statement can only be similar to this triangle, not congruent. Triangle DFG below is equilateral. JG is 6 inches, HD is 1/3 the length of DF. What is the length of FH? From the fact that this is an equilateral triangle, combined with the length of JG, we get that each side is 12 inches long. Notice that JG separates the equilateral triangle into two mirror-reflected 30, 60, 90 triangles. Knowing that HD is 1/3 of the length of one side, meaning HD is equal to 4 inches, we can calculate that HF is equal to 8 inches. Which of the following is equivalent to the expression below? As always with trig, remember the definition of these derived quantities. Cotangent is equal to 1 over tangent, or, in other words, cosine over sine. And the cosecant of x is just the inverse of sine of x. Therefore, we can express this a little more simply as 4 tangent theta times the square root of sine squared of theta plus the sine squared of theta divided by tangent squared of theta. Now we can see that the sine squared in the second term under the square root are going to cancel out, and cosine squared is going to appear as the numerator. Applying the identity, sine squared of x plus cosine squared of x equals 1, that leaves us with 4 tangent theta times 1. If y to the power z is equal to x, and 8z is equal to xy, then what is x plus y plus z if y is half the value of z? Well, here it's important to note that we have an exact expression of the dependence between y and z. This is a classic system of equations problem. The first thing that we need to do is to put all of our knowledge of the system into equation form. The second equation becomes 8 times 2y is equal to xy, because of the fact that y is half the value of z. Therefore, we can say that 16y equals to xy, and so calculate that x is equal to 16. This is going to make things a whole lot easier. Now, applying this to the first equation, we get that y to the power of 2y is equal to x. This y can trivially be calculated to be equal to 2. Another way you can do this is by utilizing logarithms, which is not going to be shown today. Applying this, we get that our final solution for x plus y plus z is equal to 16 plus the value of y plus 2 times the value of y, which is z. Therefore, this equals 22. Triangle MNP is similar to triangle RQP, and MN and QR are parallel. If the sine of the angle at R is square root of 2 over 2, then what is the measure of the angle at N? This is another case of characteristic angle values. Firstly, it's important to realize that the measure of the angle at N is the same as the measure of the angle at Q, and the measure at M is equal to the measure at R. The second thing to realize is that the angles N plus M plus P form a triangle, therefore the sum of their sizes is 180 degrees. Remembering the characteristic values of sine that we discussed before, we know that the angle at R is equal to 45 degrees, and therefore the angle at N has to also be equal to 45 degrees.